Namaskar and welcome to my channel. Today in this video we'll understand what are perfect square numbers and some related topics of squares and square root. At first let us recall what is perfect square. So a perfect square, an integer which is multiplied with itself, gives us a perfect square. So an integer multiplied to itself gives a perfect square. For example, 3 square, which gives us 9. 3 square, that means 3 into 3 gives us 9. 4 square, 4 into 4, 16. 10, let us take some more numbers. 10 square, that means 10 into 10, 100. Suppose 200 square, so we get 40,000. Don't you think that every number is a perfect square? No, all the numbers are not perfect square numbers. Only some of the numbers are perfect square. But what about the rest? So the rest numbers are known as non-perfect square. So let us see what are non-perfect square numbers. So non-perfect square numbers are those numbers which lie between perfect square numbers. Let us see. How many non-perfect square numbers exist between two consecutive perfect square numbers? So I have written a chart here. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36. So in between 1 and 4 you can see 2 and 3. So these two numbers are non-perfect square numbers. In between 4 and 9, 5, 6, 7, 8. So these numbers are non-perfect square numbers. Then in between 9 and 16, 10, 11, 12, 13, 14, 15. These are all non-perfect square numbers. But how to find out that, yes, without writing these numbers, how to find out that how many non-perfect square numbers lie between two consecutive perfect square? So let us see now. If I suppose let n equal to 1, so what will be our next number? N plus 1 will be our 1 plus 1, that is equal to 2. That means we need to find out how many non-perfect square numbers lie between square of these two. That means between 1 square and 2 square. So how to find? We'll directly find out 2n. That means 2 into 1, which means 2. In this place n I have taken as 1, so 2 into 1, 2. That means two non-perfect square numbers lie between the square of 1 and 2. Similarly, if I need to find out how many non-perfect square numbers exist between 5 square and 6 square, that means in this case your n will be equal to 5. So what will be our next number? N plus 1, 5 plus 1, which is equal to 6. So between non-perfect square numbers between 5 square and 6 square, which will be 2n, that means 2 into 5, which is equal to 10. That means what? 10 non-perfect square numbers lie between 5 square and 6 square. So let us count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there are 10 non-perfect square numbers lie between 5 square and 6 square. With this, what we can conclude? We can conclude that between squares of n and n plus 1, there exist 2n non-perfect square numbers. So with this, we come to know that in between 1 and 4, two non-perfect square numbers exist. The same way, in between 5 square and 6 square, 10 non-perfect square numbers exist. These are some of the properties of perfect square. We recall. If the numbers end in 0, 1, 4, 5, 6, then it must be a perfect square. If a number has 0 in the unit place, then the square ends in 0. If a number has 1 or 9 in the unit place, the square ends in 1. If a number has 2 or 8 in the unit place, then its square ends in 4. If a number has 3 or 7 in the unit place, its square ends in 9. If a number has 4 or 6 in the unit place, the square ends in 6. So let me give some examples of each. Like if I take an example, suppose 20. So 20 square gives us 40,000. So this number ends with 0. A number having unit digit 0 ends with 0. Same way, a number having unit digit as 1, suppose 21. So 21 square. If you multiply 21 into 21, we will be getting 441. So it ends with 1. Same way, if I multiply suppose 9. So 9 square gives us 81, which ends with 1. Same way, if the number ends with 2. For example, 12 ends with 2. 12 square gives us 144. 8 square ends with 64. So add the unit is placed here 4. It's end with 4. Same way, if a number has 3 or 7. For example, if I take 13, which will be 169. So it will end with 9. Next, 7, which is 49, ends with 9. Then the next one, if the number which has 4 or 6 in the unit place, so that number, the square of that number ends with 6. For example, if I write, suppose 4 into 4, 16, which ends with 6. Same way, if I write 6, which is 36, ends with 6. So any of the number which ends with 4, which ends with 6, its square ends with 6. Same way, if the number has 5 in its unit place, for example, if I write 15 square, which will be 225, this square ends with 5. Some more properties here. Squares of even numbers are even, squares of odd numbers are odd. So suppose if I take an example, squares of even numbers. Suppose I take an even number 4. So square of 4 gives us 16. So 4 is an even number, 6 is also an even number. So suppose if I take square of odd numbers, in this case the square of odd numbers are odd. So let us take a odd number, suppose 7. Let me take out the square of 7, which will be 49. In this case 7 is an odd number and 49 is also an odd number. Coming to the next one, perfect square can only have even number of zeros at the end. Perfect squares can only have even numbers of zeros at the end. For example, suppose if we find out 10 square, 2 zeros, even number of zeros, 2 zeros. If I suppose find out 200 square, I'll get 40,000. 40,000. That means there are 4 zeros. So which means the perfect square can only have even number of zeros at the end. So even number of zeros at the end. The next one, if a number has n zeros at the end, its square will have 2n0. For example, 10 square 100. So n0, there is only one zero here. So in this case, if n equal to 1, so what will be the number of zeros of the square? 2n. 2 into 1, that means 2 zeros. If the number have 1 zero, the square of the number will have 2 zeros. That means 2n. 2 into 1, 2 zeros. Let us now understand some interesting pattern. So interesting pattern 1. Let me write a number as 1, which is equal to 1. That means 1 square is equal to 1. 2 square 4, which can be written as 1 plus 3. 1 plus 3 gives us 4. 3 square 9. I can write 1 plus 3 plus 5. 5 plus 3 8, 8 plus 1 9. 4 square 16. 1 plus 3 plus 5 plus 7 will give you 16. 5 square 25. So I can write 1 plus 3 plus 5 plus 7 plus 9. So with this, what will be our next number? 6 square 36. 1 plus 3 plus 5 plus 7 plus 9 plus 11. If you add these numbers, you will be getting 36. 7 square, which is 49. So what can I write here? 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus, yes, 30. So these numbers 1, 3, 5, 7, 9, 11, 13. So these are your odd numbers. So what I have written? I have written the odd consecutive numbers here. That means if a number is a perfect square, so we can write in this pattern sum of consecutive odd numbers. So with this, what we can conclude? We can conclude that if a number is a perfect square, if a number is a perfect square, it has to be the sum of consecutive odd numbers. So in this case, your n is 1. In this case, your n is 2. That means 2 odd numbers you have taken. So 2 square gives us 4. In this case, n is 3. That means 3 consecutive odd numbers you have taken here. So 3 consecutive odd numbers. So 3 consecutive odd numbers, if you add, you will be getting 3 square, which is equal to 9. In this case, your n equal to 4. That means 4 consecutive odd numbers if you add, you will be getting a perfect square. Same way in this case, your n equal to 5. Here 1, 2, 3, 4, 5, 6. So n equal to 6. In this case 1, 2, 3, 4, 5, 6, 7. In this case it is 7. That means 7 square gives us 49. And if you add 7 odd consecutive odd numbers, if you add 7 consecutive odd numbers, the first 7 consecutive odd numbers, you will be getting 49, which is a perfect square number. Next, sum of first n odd numbers. So to find out sum of first n odd numbers, what we'll do, we'll find out the square of n. That means if we need to find out square of first 4 odd numbers, so what we'll do? That means if we need to find out 1 plus 3 plus 5 plus 7, what will be the sum of this first odd natural numbers? So how many numbers are here? 1, 2, 3, 4. So what we'll find? We'll find out 4 square, which is equal to 16. That means by adding 1, 3, 5, 7, we'll be getting 16. Okay. Now let us see a question which is a perfect square. We need to find out 156 is a perfect square or 169 is a perfect square. Now 156. So 156, what I can write? 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. 1, 2, 3, 4, 5, 6, 7. So 7 square, 49. 13 plus 15 plus 17 plus 19 plus 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 square gives us 121. Plus 23 plus 25 plus 27. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 square, 196. 14 square will give us 196. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 square will give us 169. 13 square, 169. Until here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 square. So 12 square will give you 144 and 13 square will give you 169. But this number 156 lie between 144 and 169. So what we can conclude? That 156 is not a perfect square. Okay, and 169, is it a perfect square? Let us see. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if we add this number, yes, it will get 169. That means 13 square is equal to 169. 13 square is equal to 169. And by adding these numbers also, I will be getting 169. So what we can conclude? The 169 is a perfect square. Next interesting pattern. Square of odd numbers is a sum of consecutive natural numbers. Square of odd numbers. Square of odd numbers is a sum of consecutive natural numbers. Let me explain this with an example. If I write, suppose, square of odd numbers 3 square, which is 9. So 9 can be written as 4 plus 5, sum of two consecutive natural numbers. Okay. So 3 square, which is equal to 9, can be written as 4 plus 5. Suppose one more odd number, suppose 5 square, 25. So 25, how I can write? Yes, I can write 12 plus 13. So suddenly how I am getting this 12, 13, 4 and 5? There should be some pattern. Let us see. Let me take one more number. If suppose 11 square, which is 121. So how I can write this number as the sum of consecutive natural number? I can write 60 plus 61. 60 plus 61 will give you 121. So how I am getting this pattern, let us see. Written as 121 minus 1 divided by 2. So that means 120 by 2 is equal to 60. And here 121 plus 1 divided by 2, which means 122 divided by 2, which means 61. So to find out square of odd numbers is a sum of consecutive natural number. So we do in this way. So this is the pattern. Suppose we need to find out the sum of consecutive natural numbers of 169. How we will find out? So 169 can be written as 13 square. Okay? So 13 square. So 169 minus 1 divided by 2, which means 168 divided by 2. So 2 8 is 16, 2 4 is 8. So first number we got 84. Next 169 plus 1 divided by 2, that means 170 divided by 2, which means 85. That means the two consecutive number which has to be added are 84 plus 85. So by adding 84 and 85, we will be getting 169. So these are the two consecutive natural numbers to get the sum, to get the square of odd number. Next, that is Pythagorean triplets. So the word Pythagoras, you got this in your previous classes. This Pythagoras theorem you got in your previous classes. So Pythagoras theorem states that in a right angle triangle, Pythagoras theorem is related to right angle triangle. So in a right angle triangle, your square of the hypotenuse is equal to sum of the square of the other two sides. So for that I have drawn a triangle here, right angle triangle, where angle B is 90 degree and the side opposite to 90 degree is known as the hypotenuse. And this is the perpendicular, this is the base. And we know by Pythagoras theorem, hypotenuse square equal to base square plus perpendicular square. But we need to know in this chapter about Pythagorean triplets, okay, which is related to Pythagoras theorem. So the definition of the Pythagorean triplets is this: with collection of three numbers. So collection of three numbers. It is a collection of three numbers such that the sum of the squares of the two numbers, sum of the squares of the two numbers is equal to square of the third number. So let us take an example. Suppose we need to find out 3, 4, 5. These three numbers are Pythagorean triplets or not. So how we will be finding this? We will find out 3 square, that is 9, 4 square, 4 into 4, 16. Then we will find out 3 square plus 4 square, which means 9 plus 16. So if we add, we will get 25. Next we will find out the square of the third one, that is 5. So 5 square is 25. So you can see adding the sum of the square of two numbers is equal to the square of the third number. So what we can say here, that 3, 4, 5 are Pythagorean triplets. That means in this case, the hypotenuse in this case is 5. Hypotenuse square is equal to base square plus perpendicular square. So 3, 4, 5 are Pythagorean triplets. So let us take one more example. If suppose we need to find out 5, 12, 13. These numbers are Pythagorean triplets or not. Same we will do. We will find out 5 square. We will find out 12 square. Then what we will do? We will add 5 square plus 12 square. That means 25 plus 144, which will be 169. Next we will find out the square of the third one. 13 square, that is 169. So you can see the two numbers are, it is equal. The third number square is equal to sum of the square of the other two. So therefore what we can say? We can say that 5, 12, 13 are the Pythagorean triplets. So our next topic is finding members of Pythagorean triplets. So here in this case I will show you two tricks here. Let us see the first trick here. So finding members of Pythagoras triplets. So the first trick I will do for a given odd number. That means there a smallest number will be given to you, which is an odd number. So given smallest member as 5. So let us see what I can do. Within 3 steps we will get the other 2 members. Okay, let us see. So in the first step what we will do, we will find out the square of this given number. So 5 square, which is 25. Then I will divide this 25 by 2. So by dividing 25 by 2, I will get 12.5. Now, in this point, you need to think that this 12.5 will lie in between which two whole numbers? I repeat, this 12.5 lies in between which two whole numbers? So, 12.5 lie between 12 and 13. 12.5 lie between two whole numbers 12 and 13. So hence we got our other two triplets. So what we got? We got 12 and 13. Is it easy? Yes. So we got the Pythagorean triplets are 5, 12, 13. So 5, 12, 13. 5 was given to us. We have find out the other two members in this way. So 5, 12, 13 are the Pythagorean triplets. Okay. Now let us see the second trick. So the second trick is for a given even number. So in case of a given even number, the smallest number in this given as 6. So what we will do? This also in 3 steps we are going to find out. So at first we need to divide the given number by 2. We will divide this 6 by 2, which will be equal to 3. So now the number that we got 3, we will square this number. That means 3 square, which will give you 9. Now 9 is a whole number, and we will think in between which two whole numbers this 9 lie. So this 9 lie between 8 and 10. So hence we got our Pythagorean triplets, the other two members of the Pythagorean triplets. So therefore 6, 8, 10 are the Pythagorean triplets.